Computer. All right. Welcome to week 3. I'm still Brother Stevic. I'm still teaching the class. Nothing has changed. So today we're going to talk about a couple of things before we begin. Any questions on anything from week 2? I see everyone who is here recorded the video and actually put your face on the video, and I appreciate that. Inevitably, there were half a dozen people who didn't do that, but that's okay. It is what it is. Free agency and all. All right. So today we're going to talk about joins. And then we're going to design a database. Don't know what the database is going to be about yet. I haven't figured that part out yet. So I'll think of something between now and the time we get there. But we're going to talk about joins today, and that's the first thing. So we keep talking about we got a database, we got tables, we have data going into them, and database have to be designed in a certain way. So actually, yeah, let's do this. Let's think this out here. Let me get my notepad up. Okay. So what should we make a database on today? Start now. Any ideas? Any it's an improv day, it's improv theater. Give me a database topic. Give me a database suggestion. I know, right? I've made so many of these. The only thing I can think about is D&D campaigns. I'm going to go D&D campaigns. Hopefully you're played D&D or is familiar with D&D or all right, so we're gonna do a database that keeps track of all the characters we've had in the D&D campaigns that we've done. So what are the tables we're gonna need? We're gonna need a character table. Character table. We're gonna need a campaign table. And then we're gonna need a settings table. And then we're going to need a monsters table because we're gonna fight some monsters. And then we're gonna have an encounters table. We'll go with that. Okay, so in the character table will only be things about the character, like their name, their race, their class, their stats. So intelligence, charisma, blah blah blah. In the campaign setting, we're gonna have location. We're gonna have just that for now. The setting is gonna be name. What is name? Name. Setting is gonna be location. Monsters, we'll put name. Just to start with these here, right? Name. And then encounters, name, uh, ID, date. Okay. So we have all these tables, and the tables have one thing in them. The one has characters, one has campaign, one has whatever thing like that, right? So we need to be able to get that information out of there and put it in a form that we can see. Because if I want to see how many characters are in what campaign or how many settings and blah blah blah, I can't get that from just one table. So I've got to do something called join the tables. So if you guys remember back to elementary school math, which I think this is still taught there. There are things called Venn diagrams. Y'all remember Venn diagrams? Were they a thing when you were in school? Let's do. Okay. So Venn diagrams, you get two sets of information. You got the orange set and you got the black set, right? So let's say the orange set is for the our database character, and this is settings. Okay. So the orange table gives me where all the characters it gives me all the characters we have in the database. Right. The settings table gives me all the places they could possibly be. But here in the middle, right, are where those two tables meet. So it tells me what characters were said in what settings here. In code terms, what I have to do is create something called a join, where I take the last we did select name from table, and we just did one table. So this week we're going to talk about how to get information from multiple tables at once. Okay. So again, here's a basic join scenario here, right? I've got I want to get the address from the address table and the city from the city table. From address city on city ID equals city ID. So let's talk about the anatomy of this for a second. We still have our select statement. We still have the columns that we want to pull from. But the columns look a little different now because they got this little A and little A dot and C dot in front of them. So these are aliases. Okay. So whenever we're doing multiple tables in a query, we have to identify for the query what table the columns are coming from. If not, the query might get confused because the same names exist in multiple tables. You're going to get what's called a ambiguous error, saying you're giving me the names of columns that are in multiple tables. I don't know what you're talking about. So the select statement stays the same, address and city, but the difference is we have these little aliases sitting in front of the select statements. My from statement's still the same, but here I have a little letter at the end saying when I say the letter A, I mean this table. It could be anything. It could be a little word, it could be 3 or 4 letters, whatever it's going to be. But whatever you put after here is the alias of this table and what you'll refer to it from there on. My new command here is inner join. Okay. Inner join means I'm looking for the stuff where the tables join. And I've got to give it a column to join on. Okay. So I'm using city ID. A couple rules about inner joins. Number one, someone had made a comment on the announcement for this week that he presupposed that you had to, the column that you did the join on had to be a foreign key. It does not. Okay. You can literally join any 2 columns between 2 tables as long as the data types match, regardless if there's a foreign key or an index on them. It doesn't make a difference. Okay. Best practice is to put the join on a column with a foreign key and an index because that makes searching easier. Okay. You don't have to, but you should. So here, and so I've got my inner join. I'm saying join these 2 tables together and then join them on this column. So the only time that you're going to get a response back from this query is where these 2 columns hold the same data in both tables. Okay. So if I do this and I run it, here's what I've got. I've got this street is in this city. This street is in this city. Okay. I can add a where clause to it. Same query as before. I'm just adding where city equals London. I can add a where clause. Not a big deal. I run it. It shows me. Oh, we help if I highlighted the entire thing. I had 2 in London. Okay. Here, doing the same thing again. I've got 2 tables I'm joining. Well, actually, I'm joining 3 tables. No, I'm joining 2 tables. I'm joining the table actor and the table film actor on the actor ID column, where the names of the actor are Nick, first name is Nick, and last name is Wahlberg. Okay. Same thing as here. Just change the table, actor to film actor, on the actor ID, and a where clause. Okay. I don't know what the name of the film is though. That's in a different table. Everyone with me? All right. So here, I'm adding in the table. I'm joining actor to film actor, and then I'm joining this to film. Okay. So remember last week I said when the front when the where the film clause, this goes first, right? So when this query runs, this goes first, and then the set that this produces, this is joined to. I'm not going to get into a lot of detail in here because it's hard to show this happening. But as you get used to writing queries and as you get used to doing this, the order in which you join the tables is critical. Because if you do them in different orders, you will get different results. So here I'm joining actor to film actor and then film actor to film. I'm getting the first and last name from film from actor and then the title from film. I don't have actor, I don't have film ID anymore. I don't need it. I'm joining film actor on actor ID and joining film to this stuff on film ID. Same where clause, but now when I run this, I've got the names of the movies. Everyone's still with me. Hey, Brandon, saw you came in late. Hope everything is great with you, sir.
Hello, I'm just yeah,
That wasn't
catching up
calling you out.
here.
That was just saying hi.
Hello.
We're all adults here. If you come in late, you come in late, dude. I'll be late some days, just not today. All right. Here, I'm joining customer to address. I'm joining the result of that to city, and then the result of this to country. On address ID, on city ID, and on country ID. My select statement, first name, last name, city, and country. Okay. So my inner joins, when I create them, take only what's in this middle area here. Only where that's matching, only where there's data that matches. Okay. This tells us where there's crossover, where things match up. This tells us like a complete set. Now, we also have something called a left join. Okay. So, what a left join does, well, we have a left join and we have a right join. Okay. So, if you're looking at this table here, character and setting, character is on the left, setting is on the right. So, if I do a left join from character to setting, what I'm saying is give me everything from character and anything from setting that matches. Which means if I have 100 characters, but only 45 are in settings, then I'm going to get all 100 characters listed on that results sheet. Only 45 of them are going to have information in the second column. So let me show you what I'm talking about here. So I've got here, I'm give me the name of the language as language name, and then the title of the film. I'm joining language to film on language ID. So it's going to give me every language in the language table. But if there's a language in the language table that doesn't have a film attached to it, it's going to be blank. I think that's the case here. So here we got English. Oh, yeah, everything has a film to it. So let me really quick do this. just to show you. Insert into language. I'm feeling very nerdy tonight. Oh, that was stupid. There we are. What am I doing wrong? I don't need that. I'm probably doing something very silly. Nah. Okay, I don't need to do language ID because that's an auto field. Last step that I can leave there. Get rid of that. Okay, so get rid of that. Here. Right, and then here, I just want. Okay, there we are. Now when I run this, Klingon shows up, but there's no movies there. Okay. Not sure what I was doing wrong there, but that's okay. So here, I'm going to do a left join. I'm going to go from inventory. I'm doing inventory and rental. I'm looking for whatever movies have never been rented. Okay. My left join is rental. My right join is inventory. And when I run this, film number 1 has never been rented, whichever one that is. Okay. Because it has no rental ID attached to it. Is this making sense about the left joins? Okay. I'm going to jump back up here for a second. That's not going to work. Anyway. Okay. Keep going here. Okay, listen. Now the right join does the exact opposite thing. It wouldn't work on this one. Won't work on this one either. So I don't have a query that's going to show you a right join, but a right join does the opposite. So here, show me all my settings that have no characters involved. Okay. This self join doesn't do anything. Oh, it will. So this self join, a self join, you can join a table to itself. You just create another version of it, give it a different name, and call it itself. So here, I'm calling the staff table twice. I forgot I fixed this one. So I'm calling the staff table twice. I'm calling the staff as S1 and staff as S2. Okay. I'm calling the first name as staff 1. The first name is from staff 2 and store ID. And basically, I'm trying to find out which staff people work in the same store. Okay. So Mike works with all these people here. John works with all these people here. Okay. So I'm just trying to find out who is in store ID 1 and 2. Okay. So there are times when you're going to join a table to itself. because the table has enough information. Like if you had a employees table, and in the employees table there was a manager column to see who someone's manager is, and that manager column used the employee ID, then you can join the table to itself to find the managers. It's not the best way to do it, but you can do it. Aaron, still with me? Have I lost anyone? Brandon, Daniel, give me a thumbs up if you're following me. All right, I'm hoping for the thumbs up. All right, so here, cross joins. Cross joins make no sense. Cross joins are weird things that someone made because they were, I don't know, not thinking straight. So what a cross join does, it's what you also call a cardinal join, I think is what it's called. What a cross join does, you've got two tables, right? You've got actor and category. So what it's going to do, it's going to take every actor and pair it with every category. So let me just, I'll do it limit 20 and then do it limit that with no limit. So when I do limit 20 here, you'll see Penelope Guinness is in everyone. And then Nick starts with the same thing. If I do this unlimited, it just basically takes every actor and puts them with every category. Um, been doing this 20 plus years, never found a valid reason for cross join. Why do you need to know it? Because there's a question on in your quiz. Is the question are cross joins dumb? That is not the question. Should it be the question? That should be the question. That's not the question. Okay. Uh three more. A couple more here. So next one. We've talked about aggregates, right? Have we talked about aggregates? Have I said the word aggregate in this class yet? Oh, maybe I haven't. No, here. So an aggregate is when you take a column and you use a mathematical function on it to get a number. So here I'm um getting first name. Oh, okay, this is kind of an aggregate. Okay. Whenever I have a aggregate function like this in my query, I must have a group by column. Okay. To tell me how to group this. So what's happening here, and this is a little advanced here. So I've got first name and last name from the actors table. I've got the count, and I'm doing a count of film ID as film count. I'm joining actor to film actor. I'm grouping by actor ID. So what that's saying is when you do the count, so what this is basically going to do is going to give me a count of how many film IDs are associated with this actor ID. Okay, it's essentially a query to give me how many movies an actor was in. If I don't use this group by clause with a count with an aggregate function, I'm going to get an error because it can't do this it can't aggregate without knowing what it's aggregating by. So when I run this, okay, so that this is the aggregate. This is the count of how many film IDs are associated with this name or this ID. Okay. All right, these are all just repetitive ones here. Hey, Jaden. Okay. So last one here. List recent rentals with customer names. So I'm getting my customer table, my first name, my last name, the date of the rental, and the title, joining from 1, 2, 3, 4 different tables, and ordering by rental date, and it gives me everything. Don't ever do this. Ignore that one. All right. Well, let's talk about that for a second. I shouldn't say that. So here I've got all these inner joins, right? So whenever you're doing an inner join, you and use that on clause, you're telling it what column to use. And this is very clear and understanding, and we understand what this says. If you're lazy, and you shouldn't be lazy, you can use this word using. So you join the film ID language ID using language ID, and that's essentially like saying on language ID equals language ID. This does not work in anything outside of MySQL, I don't think. But it's just another way to do it. Any questions? Everyone good with joins? We'll be talking a lot more about. Oh, who chatted? All right. Thanks, Brandon. Um, we'll be talking a lot more about joins in the coming weeks as we do this. But right now, I'd like to jump into showing you guys, kind of walking through with you guys how to design a database from the ground up. Talk about data types and things like that. All right. So when you're designing a database, I strongly suggest you go to File and go to Open New Model, and you get this little screen here. We're going to add a diagram. Okay. Now, here is where you can design your database as a graphic, as opposed to trying to do it in code. And, spoiler alert, um, if you do it here, you can convert it into code. So you don't have to write the code. So for those of you who are playing with the idea of, oh, I gotta talk about a project too. Oh my gosh. Let me do that real quick first. I can't forget the final project. Hang on, let me stop sharing here for a second. Mm, stop share. Let me pull this up here. I forget it about this. Okay. Hang on. Back to here. Let's share again. Okay, signing into Canvas. Oh, okay. Going over to here. Going into modules. When you are in week 3, you're going to see something that says uh, final options. Okay. You have a choice. You can choose to do a final project, or you can choose to do a final exam. You do not have to do both. People will do both. You do not have to do both. Pick one. Um, with the final project, what you are going to do is you are going to design a database. You're going to come up with a business. You're going to create a database for that business and consider a front end application for that database. You don't have to make the front end application. This isn't a development class. This is a database class. So feel free to do the database and play with the front end. The database must have a minimum of 10 tables. Don't go past 10 tables, because if you go past 10 tables, you never stop at 11. It's like potato chips. You just half the bag is gone by the time you're ready, when you realize what's happened. So stick around 10 tables. Okay. When you um uh create the tables, you need to give me one of the things you have to give me is an entity relationship diagram, which I'm about to show you what it is. Okay. That's one thing you have to give me. You also have to give me the the code to make the table. And I'll put this all in the announcement, but it's all in here too. Okay. these two kind of go together. You need to create for me insert statements to put at least 15 rows of data in every table. I also need you to create CRUD statements for each table, which is create, read, update, just update and delete for each table, showing me how to. You can do the insertions here in the data population, but I need to write me a code to do an update statement, a code make a delete statement. Okay, don't worry about that part. Then I need you to write three what I call business cases. What are you going to use this database for? What is the data that your customer is going to want out of there? Okay. So you'll go and you'll create these tables and create this database, insert all the data, and then you're going to create queries to pull the data out to show me how it would be used. You're also going to create two views. And we'll talk about those later on. That we'll talk about those somewhere around week 9 on how to create views. So just don't worry about that part yet. Okay. And then give me the scripts for those. So far, you got to give me an ERD. You got to give me the code to create the database. You got to give me your CRUD statements. You got to give me the code for your 3 business cases and your views. And then you've got to create a fifth thing for me, a 3 to 5 minute video presentation or a PowerPoint presentation explaining your project. Okay. This all gets submitted to me by the end of week 13. Yep. By the end of week 13. Okay. What you're doing, what the database is, the code to make the database, the code to insert, to do the CRUD statements, the code for the queries and views, and then the final presentation. All sent to me in a nice little package on week 13. Also, if you're doing the final project, your weekly writing assignments, the Possum database thing, they don't have to be done anymore. What the weekly writing assignment turns into is a correspondence from you to me to let me know how you're doing on the database. Any questions you have, any thoughts you're having, any feedback you want to show me your ERD, show me your ID, you got a question on a view or something like that, you ask it there. That is kind of like a journal entry telling me, hey, Brother Stevic, this week I figured out my database is going to be on a dog grooming. And this is why. And then the weeks that follow, I've worked on this, I've worked on that, I've worked on this, I've worked on that. If you want to continue to do the Possum database, that's entirely up to you. But those writing assignments in the week become my insight into you doing the final project. Okay. It's difficult to mimic a real in-person class because normally I would like if we were meeting once a week in a classroom setting, like at some point in class, I'd ask you, hey, how are you doing the final project? Where are you at? What's going on with it? Blah, blah, blah. Right. I can't do that here. Because I'm at week 3 and I got the same 5 people coming in, which is fantastic. No one's dropped yet. Please don't drop. I like having people here. I will talk to myself if I have to. It just gets weirder. Right. Um, so yeah, so this is the way I keep touching me. So if you choose the final project, and I always encourage the final project or the final exam because it's a far more interesting choice. Now, let's say you decide you're doing the final project. You've done 10 weeks of work on it. But then on week 12, you're not done yet and something happens and you can't finish the project. Do the final exam. Tell me, hey, Brother Stevic, aliens showed up on Thursday. We went out and hung out on their planet for a couple days. Came back. I ran out of time. They sent me back a picture that us meet with them for you to show you I did this. But I'm not gonna finish the final project. I'm like, That's cool. I know those guys. We met before. Tell them I said hey and do the final exam. Okay. Um, if you have kind of chunked at it every week for the next 13 weeks, you shouldn't run into that problem. But as we all know, stuff happens, life happens. Don't sweat it. Um, if you got to do the final exam, do the final exam. I'm not going to count it against you. I'm not going to be mad at you. I'm like, all right. All right. Any questions on the final exam? That's pretty much it. Make sure you refer to here. Jaden, what's up?
Yeah. So I was thinking of overlapping this with my freshman discovery project thing that I'm doing. So for that, I'm planning on implementing a SQL database into the larger project. With that, would you want to see the full thing or just the database, or how would that go?
I would just need to see the database, but if you want to show the entire thing, I'm not going to say no. Oh, I find this stuff interesting. So yeah,
All right.
I am not a front end developer by any stretch of the imagination.
Neither am
I
I.
did that for a while. Fun fact about me, I was one of the first 200 people in the world certified in the C sharp language when it was released in 19, no, 2002. It was a horrible test. I don't recommend taking it. It was miserable. I was one of the first people, 200 people who took that test. And it was a bad test. It was a very, very bad test. But I used to C sharp develop, I used to J sharp develop, C++, all that stuff, but I didn't want to do it. Oh, hands up. Okay, am I back? Am I back? Am I getting green here? Yeah, I'm good. Okay, okay. All right. Any question on the final exam? Or final project, rather. All right, let's go back to designing a database. Boom. All right, so the database I threatened to make was keeping track of characters in a D&D campaign. I'm going to make a database for that. So the first table I'm going to need is characters. Character. All right. Character. All right. First thing I always need is an ID column. Now, let's talk about data types. I threatened that I would do this last week. I'm going to do it now. A data type is a very interesting thing because, all right. So when we're talking about this data type int, right? That's not the only one. There's tiny int. There's small int. There's int. There's medium int. And there's big int. A lot of ints. Now, the numbers I'm about to use will not be completely accurate because I didn't look them up again before I talked about this, but I'm going to give you rough ideas. Right? So tiny int is, I think, negative 256 to positive 256. Small int is, let me look this up. Hang on a second. I really should remember to do this, but I always forget to. Show me all the int data types, their range and size. All right. So, as it's thinking, and this is 1 bits. Okay. Okay, so here, I lied. So this is negative 128 to positive 127. This one is negative 32,768 to positive 32,767. Int is medium int. That's important. That's fine. Medium int is negative 8,388,608 to 8,388,603. Int goes from 2.1 billion. I'm just going to do this. Negative 2.1 billion to positive 2.1 billion, 2.1 billion. And then, good grief. Big int is, okay. What is this? 9 billion? Nope, that's trillion. Yeah, it's negative 9 trillion to positive 9 trillion. So big int is huge, right? So this guy's 1 byte. This guy's 2 bytes. This is 3 bytes. This is 4 bytes. And this is 8 bytes. It actually doubles from there. Okay. Now, the reason this is important, every time when you've got a table, every column you have not only tells you what's going to be in it, but how much space that's going to take up on the hard drive. Okay. Which means if you use tinyInt, that entire column will be 1 byte. If you've got 1,000 rows, it's 1,000 bytes. It's next to nothing in size. It's little. It's a bitty guy. No one's mad about it. If you choose big int, each row on that one column holds 8 bytes. And if you have 1 billion rows, that's 8 billion bytes, which is a lot of bytes. It's several terabytes in space, maybe some petabytes, right? Um, so when you choose your data type, you've got to be wise in the one you choose because you've got to look to yourself, how many rows, how big is the number in here actually going to get? And I will tell you a story. When I worked for a company called Property Insight, it was a property title insurance company. And the purpose of the database that we had was to allow title agencies to research titles to determine when you buy a house, so they're going to do a title search to make sure no one owns it before you and you're not lying, stuff like that, right? So we had 15 different states worth of titles. When the sales table was created, the sales ID was set to an int when it was created in the late 90s. They never thought they'd reach 2 billion rows in that table. Fast forward to 2015 when I was getting there, when I got there, they were at 2.1 billion rows. And they were on track to run out of numbers in about 3 months. So we had to take the database offline and convert that column to big int, to the 9 trillion number. Here's your guess. How long did it take to do that? We started Thursday at 5 p.m. on a holiday weekend. When did that process finish? Give it to me in what you think it was. Was it hours, days, or weeks?
I want to say days,
It was
hopefully
days.
like through the weekend, and that's it.
It was six. It was very close to 5 days. It was Thursday, Friday, Saturday, Sunday, and almost all of Monday. Tuesday morning was back up and running. Because what happens last week, I kind of pounded into you guys that it goes row by row. So what happened was we had 2.2 billion rows, and the process touched each row and made it bigger each time, each time, each time. So it took some time to do that. But the other thing that was happening behind the scenes, which is why it took, the database was growing. That column literally doubled in size from 8.8 so it was 2 billion it was 2 billion rows. So it went from 8 billion bytes to 16 billion bytes. And if you don't, luckily, I was smarter. You can pre-grow the database so it doesn't grow automatically because database will grow automatically as it gets too big. Kind of like how you wish your pants would do that on Thanksgiving Day, right? It doesn't do that, but like your database will grow automatically, but it grows really slow. It grows like 10 gigs at a time or whatever you set it to. So I pre-grew the database. I doubled the database in size. I forget what the sizes were, but by the time we were done, it was at that time a hefty lad of about 650 terabytes. I mean, 650 gigabytes. The database I deal with now are 30, 40 terabytes with 20 billion rows in them. Right. So when you're choosing your data type, it becomes very, very important that you choose the right data type for what you're going to do. So it also requires that you plan ahead so you understand what this data type in the business will be. Because if you have got to change it at any point in time, it is a nightmare. So here, you got a character. So I'm just gonna go with I don't anticipate having that many people on campaign. So I'm gonna go small int here. So you do character name. Now here we got varchar. So you've got char and you've got varchar and you've got text. These are numeric, these are textual. Okay. Char and varchar are always followed by a number. Text isn't. So we'll say, let's say char 45 and varchar 45. Difference here is if I do char 45, every row that exists with that column takes up 45 bytes of space, no matter what's in it. So if I've got 45 of char 45 and I put the letter P in there, it will still take up 45 bytes of space. Or it'll take up to 45 characters. Okay. So it takes up, which is essentially a byte. But it will stay that size. If I do varchar 45, it can grow up to 45 characters. So if we put the letter P in there, it is essentially one, but has the ability to grow 44 more. Text, however, will take whatever you throw at it. It will take the King James Bible if you wanted to put it in there. Just copy and paste it in. It's an indexing nightmare. I would never do it, but you could if you wanted to. There's also this one. So never use this one. Y'all know what XML is? Are you familiar with XML? Oh, look at Cason's laughing. He knows. The same company I worked for that did the whole in thing. Microsoft came by and said, "Hey, you know what we can do? We can use XML in your database, in your table, and create a whole database within the table in a column." That was bad. Don't ever do. Yeah, I don't know why they did either. Well, they did it because when the states sent us the information for the title insurance stuff, like they sent a lot of information and a lot of it we didn't use. And they didn't want to lose the data. So they created a small database in the table, in each column, in each row. So each row, if there were like 25 fields that weren't included in the table, they were included in the XML column. That was a nightmare. I got rid of that as soon as I got there. All right, so don't ever use that. All right. Well, it's 1022. Okay. So name. Let's do we need race. We need class. We need let's just leave it for that right now. Okay. Because there's other stuff that go in there. But remember, the stuff that goes in character is only that deals with that one character. Okay. We could do stat, we'll just do it differently. Okay, so here. Now, when we talk about normalizing data, let me do this here. Let me do one more thing. Let me do module. Okay, we'll do that. The module they were in. Okay, so now, um, when we talk about normalizing a database, we mean two things. One, making sure the data that's in there is unique and non-repetitive to that table. And two, we make sure that the data that's in there cannot be ruined by end users. Okay. So I've got three columns here. I've got race, class, and module. Look at module. So one character can be in many modules, right? If you don't play D&D, just go with me. One character be many modules. So if I have module here, do I do like module one, module two, module three, module four? No, that's not going to work because that becomes what's called a many-to-many relationship. Okay. So what I would do in this case is I would create another table and have it called module. And for the sake of time, I'm just going to make a module ID here. I'm going to make it a small int because actually, I'll probably just make it a tiny int because I don't know that many people are going to play D&D with me. Uh, okay. Tiny int. There. No int. Now, I don't want this module column here anymore, so I'm going to get rid of that. And what I can do here is I got this bar over here. These are one-to-many relationships. This is one-to-one relationship, and this is many-to-many relationship. So if I take this guy over here and click him, and then click these two tables, it gives me a bridge table automatically. So I don't have to think. Now notice that this got a little yellow key here, a little yellow key here. Those columns are designated the primary key, just by default. Notice I got two red keys here. The primary key of a table can be more than one column. It can be up to three. But those three must meet the criteria. They must be unique, and they can never be null. Okay. So this satisfies my first problem. I only have data that's unique to the character here. So I've got the module here, I've got the character here, and however many characters in the however many modules that character's in, I can just fill it out through here. Is that making sense? Everyone with me? Okay. Now, I've got name and I've got race and I got class. Um, the reason I'm gonna do this is a couple of reasons. One, I make a race table. Okay. And we give a race ID. I make that a tiny int. All right, and then the name of the race. Now, the reason I'm going to do this is because I don't want people. Imagine how you insert the data into a database. Eventually, you're going to make a front end for this, and people are going to be able to insert things on their own. I don't want them typing it into a text box, and A, hoping they spell it right, and B, hoping it's a real race. You know, people could spell dwarf 18, 20, 35 different rays. It's only a 5 letter word. They might come up with a new, a Califrax, make up a race. That doesn't exist. I don't want that there. So what I do is I get rid of the race in this table here. And then I do my one to many. I did it the wrong way. I'm gonna do it the right way this time. Do my one to many. And now I've got a race ID here. Now this does a couple things. Notice how it's got a little red diamond there. That means it's a foreign key. What a foreign key means is if it doesn't exist in this table, it can't be in this table. So I'm only allowing people to use races I have pre-chosen in here and into the character. So what would happen in a front end? You'd have a drop-down box that contained the contents of this table, and they could pick the race that they want. I'm going to do the same thing with class. Class ID, and then name. Go back here, remove class from the table. And then do my one to many. Okay. Any questions? We all still doing good? All right. So we didn't get as deep as we wanted to this because I got into did my whole spiel on the data types. But the most important thing here, couple A, you understand about bridge tables. You understand about keeping the data clean by not letting people type stuff in and giving them drop-down menus or giving them specific choices on how foreign keys work. But the most important thing I'm going to show you tonight for your final project is how to take what you did in the pictures and turn it into code. So you don't have to write the code. Okay. So I got my pretty picture here. This, by the way, is your ERD. When this is done, you send it to me. Screenshot, please. Just a screenshot or a snap or whatever it is. Don't send me the MDF. Please don't send me the MDF. You go here to database. You go to forward engineer. Yep. Go to forward engineer. Click next. You're going to generate everything. Okay. Leave all these unchecked because you don't want to just let it do it on its own. One of the few times you trust the robot. Export every object. Next. And there's your code. And then you copy it to the clipboard, you put it in your thing, and you create it. Okay. Note that if you make a change here in the ERD, after you create your database, you have to recreate the entire thing. It can't give you a delta of the changes. Or you can, or I would suggest you just change yourself. Okay. I spent about 5 minutes doing this and I got 5 tables. If I kept going with what I had planned to do with this, I'd be about 14, 15 tables pretty quick. Okay. So this is a rough idea on how to create the database, get the forward engineering done, and this is the first 2 big steps of your final project. Okay. So if you're choosing to do the final project, I strongly recommend this week to figure out what you want to do it on. I don't do it on genealogy. That's too big. It's way too big. Um, try to do something small. Um, uh, but something that's of interest to you. If you collect bugs, make a bug database. Whatever you want. All right. And like in this week's writing assignment, kind of throw the idea to me. Say, I'm thinking about this. All right. All right. It is 10:32 here on the East Coast. Which means I gotta go to bed, and it's 8:32 in Idaho. Is it 8:30? What do you 2 hours difference or 3 hours difference in Idaho? 2 hours?
It's 2 hours. It's 8:30
Oh,
here.
so it's 8:30. So you guys still got all sorts of time before you got to go to bed. I'm old.
Yep.
I'm heading to sleep here in a few minutes. All right.
Alright.
Any questions before we go? Any questions on anything we talked about tonight? Any questions on the assignments? Any questions on anything?
I had one question about my final project that I was
Yep.
thinking of doing. Part of it I want to do kind of recipe storage. How would you go through implementing like the steps for the recipe and saving that in a database? Would you just do one thing that is just text and then have it all in that one part, or?
There's a couple ways to do that. What I would, if I were doing it just off the top of my head, I would probably have a bridge table and have a
Okay.
set of like there are probably some instructions that are like standard, like preheat oven and things like that. You could do it in a text field. The problem with that is formatting it on the front end.
Yeah.
Yeah, so yeah, I would either do it as a text field or I do it as I would do it as a bridge table.
Okay.
Or not, you wouldn't even have to do a bridge table, just do an instructions table and have the recipe ID in that step.
Okay.
That way you can edit the individual steps. The more granular you get, the better it's going to be.
Okay.
So we can play with if we have some time one Tuesday after my lecture is done, we can kind of play with that.
Okay.
Oh, also in these meetings, after week 9, I don't talk about code anymore because I've planned this out to where all the coding will be in your hands and how to do it by week 9. So weeks 10 and 11, the last two classes we'll have in person are just to go over your databases.
Okay. Yeah, sounds good. Thank you.
No problem. Any other questions? If not, I release you into the wild. Until next week. Bye, guys. Thanks for coming.
Thank you.